Hi, this is Algebra 2, Lesson 42, and we're going to talk about estimating with scientific notation. We're starting on page 187. In this lesson, we're going to begin to work with more complicated scientific notation problems. So, to review, we have 0.0003 times 10 to the negative 6 times 4,000 all over 0.006 times 10 to the 15th times 2,000 times 10 to the 4th. We simplify this by rewriting it all of the terms in standard scientific notation. So in this one, we're going to move the decimal to the right of the first non-zero digit. 1, 2, 3, 4. So we're moving that 4 to the right, so this will be 3 times. Moving it 4 more places to the right, so this will be 10 to the negative 10 times. This one's being moved 1, 2, 3 places to the left, so this will be 4 times 10 to the third. That's a 3. This one is going to go 1, 2, 3 places to the right. She'll change this to 6 times 10 to the 12th times 1, 2, 3, 2 times 10 to the 7th. Okay, now we can simplify this mess. We have 3 times 4, and we have 10 to the 10th, and 10 to the 3rd. Over here we have 6 times 2, and we have 10 to the 12th, and 10 to the 7th. Okay, 3 times 4 is 12, and 6 times 2 is 12, so this cancels, and it's going to leave us with a 1. That makes life easier. And then we're going to have this fraction. We have 10 to the negative 10, and 10 to the 3rd, that's going to be 10 to the negative 7. We have 10 to the 12th and 10 to the 7th, so this is 10 to the 19th. Alright, and we're going to take care of these by subtracting. Right? We've handled this before. The 10s are the same base. This is going to be negative 7 minus 19. So this is going to be 1 times 10 to the negative 7 minus 19, which equals 1 times 10 to the negative 26. Real-life problems contain numbers that are not very easy to handle. For example, the answer to our last example in lesson 41 was 16 times 5,280 times 5,280 times 5,280 times 12 times 12 times 12 inches cubed. Multiplying these by hand would be tedious, and we might make a mistake. If we use a calculator that does not have scientific notation built in, we'll get an error message because the answer will take more digits than the calculator can display. Because it's so easy to make mistakes when doing these problems, it is often helpful to begin by estimating an answer. That way, when we find our final answer, we have an idea whether it's a reasonable answer or not. If we estimate that the answer of our unit multiplier problem is somewhere between 4 and 10 to the 14th and 4 and 10 to the 16th inches cubed, and for our final answer we get something crazy like 4.0697 times 9 to the 21st power, we know our answer is off by about 1,000,000 times, which would not be a reasonable amount. It would not be a reasonable answer. So we're going to start by estimating this, and we're going to do that by rounding all of the numbers up to one non-zero digit and writing them in scientific notation. So 16, we're going to make it in scientific notation, so our decimal is going to go here, And the 6 is going to make the 1 round up to 2. So we've got 2 times 10 to the first, because we moved the decimal just one place. Okay? 5,280, we're going to put the decimal here. The next digit back is a 2, so the 5 is going to stay where it is. So it's 5 times 10 to the third, because we moved the digit 3 places. And 12, we're going to move the decimal 1 place, and the 2 is not going to change the 1. So it's going to be 1 times 10 to the 1. All right? So when we put this back together in estimated form, these are not equals, these are estimations. We're going to have 2 times 10 to the 1 times 5 times 10 to the 3 times 5 times 10 to the 3 times 5 times 10 to the 3 times 1 times 10 to the 1 times 1 times 10 to the 1 times 1 times 10 to the 1. Okay? Alright. So when we put these together, we've got 2 times 5 times 5 times 5 times 1 times 1 times 1. Okay? Times 10 to the, and we're going to add the powers together. We've got 1, 3, 3, 3, 1, 1, and 1. Because we're actually multiplying these powers together, we're using the product theorem here, which means we're actually going to multiply all of those together. We're going to add them all together. So that's going to be 10 to the 1 plus 3 plus 3 plus 3 plus 1 plus 1 plus 1. Alright, let's start here. 5 times 5 times 5 is 125. Times 2 is 250. Times 1 times 1 times 1 just leaves us with 250. Times 10 to the 1 plus 3 is 4, plus 3 is 7, plus 3 is 10, plus 1 is 11, plus 1 is 12, plus 1 is 13. Alright, so we have 250 times 10 to the 13. We're going to put this back into correct scientific notation form, and once again we're going to round this up so it's to 1 digit. So this is going to equal approximately, the 5 turns a 2 into a 3, 3 times 10 to the 15. Okay? That is our estimated answer for this craziness. Now, you need to notice that we rounded the 5,280 down quite a bit, and we did it 3 times. So our answer is going to be bigger than this. When we type this into a calculator or do it for real, the answer is going to be bigger than this. But it's not going to be a lot bigger. Or it's not going to be bigger by a factor of 1,000,000. The powers are going to be very close. This number is going to be higher. Okay? So, if we use a calculator on the original problem, we are actually going to get 4.0697 times 10 to the 15th. So our estimate was very reasonable. We've got 10 to the 15, and it's higher than the 3. Okay? And this is still a really stinking big number. Inches cubed. Alright, when we use these, we're going to rewrite our answers in standard form, and we're going to round to 1 digit. So this would round this up to a 1. So this would be 4.1 times 10 to the 15th inches cubed. So let's try a few. Use scientific notation to help estimate the answer to this problem. We're not going to plug this one into the calculator. We just want to see the estimate this time. So we're going to start by putting these into standard scientific notation form, and we're going to round to the first digit. So this one's going to move up 3 times, and the 7's going to change the 3 to a 4. So we're going to have 4 times 10 to the third. This one is going to round up 1, 2, 3, 4, 5 times, and the 7 is going to round the 4 up to a 5. Alright, so I said it's going to round up 5 times. This is already at negative 14, so now it's just negative 9. Here we have 278,146, so we're going to move this decimal up 5 times. The 7 is going to move the 2 up to a 3. Grief. We'll have 3 times 10 to the 5th. And here we have a big decimal. 1, 2, 3, 4. We're moving the decimal 4 to the right. The 1 will not change the 7, so we'll have 7 times. We move the decimal 4 times to the right, and it's already at negative 5, so now it's negative 9. Okay? This is going to equal 4 times 5 is 20 times 10 to the third times 10 to the negative 9 is 10 to the negative 6. So we add the powers. Here we have 3 times 7 is 21 times 10 to the 5th times 10 to the 9th is 10 to the negative 4th. Alright, so the fraction of 20 over 21, if you punch that into the calculator, is going to be a very large decimal that's going to be approaching 1. Because 21 over 21 would be 1. So 20 over 21 is going to be almost 1. Okay? So we're going to round that up to a 1. This is going to be 10 to the negative 6 divided by 10 to the negative 4, which means we actually do negative 6 plus 4. This changes to a positive. Negative 6 plus 4 is negative 2. So our estimated answer is 1 times 10 to the negative 2. So once again, we're going to be using scientific notation to help estimate the answer to this problem. We're going to start by rewriting each of these terms into standard scientific form, and we're going to round up to the nearest non-zero digit. So, in this case, we're going to move the decimal 2 places to the right, and the 1 will not change the 4 into a 5 because this 1 is less than 5. So we have 4 times 10 to the, it was to the negative 14, now it's going to be to the negative 16. Right? Here we have 41,725 times 10 to the 43rd. We're going to move this up 1, 2, 3, 4 places. This 1 will not change the 4 to a 5, so we'll have 4 times. We moved it up 4 more places, and it was already at 43, so now it's at 47. In our denominator, we have 9,764 times 10 to the negative 23rd. So we're going to move this decimal up 1, 2, 3 places to the left. The 7 will change this 9 to a 10. So that'll be 10 times 10 to the, we moved it left 3 places, so this will make this 20. And now this is no longer in standard form. We can move this decimal 1 more place over. So it will equal 4 times 10 to the 16th times 4 times 10 to the 47th over 1 times 10 to the negative 19. Okay? 4 times 4 is 16. Times 10 to the negative 16 plus 47 is 31 over 1 times 10 to the negative 19. Okay, this is 16 divided by 1 is 16 times 10 This will be 31 minus 19, which will be 50. All right, now we need to put this back into standard notation, so we're going to move it up there, and because we're estimating, we're going to round up to the nearest whole number. So this 6 is going to turn this 1 into a 2. So this is actually an estimated, so it's approximately 2 times 10 to the, we're moving the decimal one more time, so it'll be 51. Okay, so that is the estimated answer to this more complicated problem. That is it for this lesson. Try your practice problems and your homework and let me know if you have any questions. Thanks.